All right, so here's the graph of x squared, and here's a different function. The question is, which of the following is this graph? Now, a lot of you have done this assignment already, maybe a couple times, maybe just missed a couple things. So I'm going to assume that you realize a couple things. The first one is that any kind of number change inside the parentheses actually means what? The opposite, right? So even though this says we're going to add 5 to x, it actually means that the shift is left 5, right? We thought of this as opposite land before. You know what I'm saying? Okay. Now this number is not in the parentheses, so that actually means down 3. So pick any important point on any graph, and then let's just shift it. So let's go. Here's your vertex. Let's go left 5. Keep in mind some of these scales on the graph labels are not just by ones, right? So left 5 is actually here. And then down 3 is actually here. So our new graph should look something like, that over here somewhere. Should be left 5 and down 3 from the origin. That one? Nope. That one. But you could see if you're just counting boxes, you might screw that up. Okay, let's do another one. Here's your function. It's 2x squared. And then it says graph the function. Has the same 2. Let's ignore that. We're not changing that part, right? The only thing we're changing is the shift. So one problem is we need to kind of first get this all lined up, right? If we are just translating something, that's what a shift is, a translation back from geometry, then the shape and the size are the same, right? You're just sliding it somewhere. So when they give you a question like this, let's line everything up to make it the same size and shape. And then let's shift it just like it says here, left 1, down 8. Let's do that with each point. Each point gets both shifts, right? So left 1, down 8. This point, left 1, down 8. It should be the same shape, similar shape graph, right? It should be parallel if you were somehow lining up parts of the graph. All right, let's do another one. Here's the graph of h of x. Which of the following is a graph of h of x plus 4? What does this mean? Tell me. Yeah, shifted left 4. So let's pick an important point like the vertex. Let's shift it left 4. Right now it's at -2. So if we go left 4, it should be at -6, right? Keep in mind the scale is going to be different for each one. Make sure it's the same height, right? No other vertical shift. All right, let's kind of get into a couple of the tougher ones. Here's one of them. All right, what happens when you go from G to H? So let's look at that one more time. It says write a formula for H in terms of G. So here's G. Let's start there. Whenever it says this, write it in terms of G, your answer will have a G in the equation. There's another one that looks like this, right? And it has actual equations with like square roots and parabolas and quadratics. But on this one, it says write it in terms of G. So let's start at G and let's go to H. How do we get there if we start at G? Well, you have to go left 5 and up 1. Left 5 and up 1. Well, if you go left 5, then this better say plus 5. And if you go up 1, then this better say plus 1, like that. Okay, there's another version of this I want to get to where you actually have to write the equation. So let me kind of skip through some more questions here real quick. All right, so right here. it says f of x is a transformation of g of x. But if you notice, the size and the shape is the same. So that means everything's going to be the same. The only thing that's going to change is the shift. So it says g of x is this. What's f? So that means we're going to start. Well, let's look at g really quick. This is an important point for g right here, right? Where is that? Yeah, negative 7, 1, right? So if we look at the equation for g, this shows right here. It's left 7, left 7, and up 1. The 2 does not really matter. Okay. What it does mean is that since these two things are the same size and shape, we have to also include a 2 here when we write the equation. Notice on the last one it said write it in terms of f or g or something, right? This one says write it in terms of x. So we're going to have to actually write the square root function. Now, that's for g. Now take a look at f's graph. Where's f's important point? This, quote, vertex or starting point. Negative 3, negative 2. So we're going to say plus 3, minus 2. I am not comparing one to the other. I'm comparing it to the origin. Okay. On the previous example, we are counting from one function to the other. Okay. Why am I saying to the origin? Well, take a look at how they wrote the equation for g. Where did that 7 come from? Well, that's because it's over 7 and up 1, right? So if I'm writing the equation for f, I better do it the same way. I have to leave everything else the same. This 2 we'll get to later on this week, but that's a vertical stretch. But that does not apply to these shifts. Okay, so that was 2 different kinds of questions there. Again, on this one, we're comparing it to the origin. On the previous one, we're comparing one function to the other. All right, if you get one like that, holler at me if you have a question. Let's take some time to work through that. If you've done it already, maybe just try to do it one more time here just for practice.